In this video, we will search, sort, and paginate using Deno and MySQL. Before we start building the app, I would like to remind you that this video can be combined with other videos. So if you want to use Deno with any of these front-end frameworks, or Deno with MySQL or MongoDB, I provided some links in the description of this video. If you don't want to combine them, don't worry, the combinations are optional. Now let's start building the app, and also make sure to check scalablescripts.com. Now let's create the Deno project. Here is deno.land, the main page of Deno, and here is my empty folder. We will create the project. So I'm using PHP Storm here, but you can use Visual Studio Code, it is the same. Here I'll create a TypeScript file, app.ts, and we want to add some Deno code here. So the usual example, before you install Deno, of course, if you haven't installed it, use one of these commands. And I will copy this code, paste it here, and this is the first Deno project, and we can run it by using Deno run app.ts. So Deno is secure by default, and if you want to use the port to access localhost, we need the flag allownet. So to run this app, run Deno run allownet app.ts, and now we are listening to port 8000. Hello world. So everything is correct. Now I will change again this code, because we will be using third-party modules, and in the third-party modules I will write here awk, and this is the package that I want. And to run an application using awk, so I will copy this code here, and I will change this. So it is the same, but awk provides more functionality. So if I run this again, it's running because we didn't add here the console log. So I will add a console log listening to port 8000. Note that when I save, the app doesn't refresh. To change this behavior, I will close the terminal now, and I will run the same thing, but with the watch flag. So if I do it like this, if I add an exclamation point here, save, and file change detected, restarting, and listening to port 8000. So during development is good to add the watch flag, and this will be the same. So we are returning hello world here, and now let's prepare the app. So I'll go back to the third-party modules, and I will add course. So first, what is course? Course stands from cross-origin resource sharing. If you want to use this app with another frontend, you can use it, but you will have course problems. So you have to add this package to prevent the course problems. So I'll import it here, import from this URL like this, and I will import awk course. So this app will run on port 8000, and the frontend will run on a different port, and the browser will prevent that. And if you want the browser to allow that, you have to add the course. So I will add it here, app use awk course, and inside I will add the origin. And the origin will be a regular expression here. So since we will use multiple frontends, so this will be like this. So it will be localhost. This in front says that we can have anything. So this will be HTTP or HTTPS. Localhost with the port 3000 for React, 4200 for Angular, and 8080 for Vue, and $sign. So that's it. If we add this origin, all the other frontends will consume the endpoints here. So we need to add also the routes. So we can add here a router, and we can create the router here is equal to new router, and I will use the endpoints later. So first our app will use a router that routes, and it will use the allowed methods, and that's it. So we added the necessary configuration. We will add later the routes, but now we need to connect with the database. So we will use MongoDB in this example. So I will use Mongo here. So this is the MongoDB driver, and to use it I will copy this code here. So I copied this, and I will create a directory here, database, and this will have a TypeScript file here, connection, and I will paste this. We don't need Bison, and we simply need to create a Mongo client, and this will be our connection with our localhost, or you can put an Atlas URL here. You can do whatever you want. Slash, we need the database name, so Deno search will be my database name, and I will export a constant here, export constant db is equal to this, because we need to use that database. So I added this, and also we need to create a schema, not here but here, schemas. Inside I will create the product schema, so product.ts. We'll export an interface product schema here. This will have an ID, and this will be a type like this, so as a string. So this will be the MongoDB ID. We need the title as a string, description as a string, image as a string, and also price as a number. So we added the connection, we added the schema, and now in our app.ts, let's get them. So first I will get here the database, so I will get the products is equal to database. So my ID already helps me, so we need to import the database from the connection. Collection of products, and the type will be product schema. So we need to import that too. So with this we successfully connected with our database. So if we restart the server, it will work fine. So we have an error, connection refused. Sometimes this happens, and if that happens for you, you have to change this localhost to 127.0.0.1. Not sure why that is the case. If I change that, it will work fine. So that is working correctly. Also, when I make changes here, I want to restart every time, so I'll stop this and I'll add a watch here. Because I don't want to stop and start again, so we are listening to port 8000. If I add an exclamation point here and I save, file change detected, restarting and listening to port 8000. So this is working fine. We connected with our database. I will move it here. And now what is left is to get an endpoint, so router. Let's send a GET request to API/products/frontend. And this will be a function, an asynchronous function that will have an object. So the type will be a router context. This object will be a router context here. And what we want from the router context is the response. So response here. And what we want to return is response body is equal to await products find like this to array. Because if we do find, just find, it will return just a string. This to array will return the products as we want. So let's see the actual response. So the server is restarting. To test this endpoint, download and install Postman. I already did it. And let's send a GET request to HTTP localhost port 8000/API/product/frontend. Let's send this request. And of course, we are getting an empty array. So we don't have any products in the database. To return some products, we have to fake some data. And to do that, I'll create here another file, cedar.ts. So we will use this file in order to populate our database with fake data. The first thing that I will get here is this products. So I'll paste it here, and also don't forget the imports. And now I'll do a for loop here for let I is equal to 0, I is less than 50, I++. So now let's create 50 products. To create 50 products, I will create here a variable list is equal to an empty array, and the list will push to these objects. So we want to add the title, the description, and the image and the price. So the actual product data here. And before adding them, I will add another package, which is Faker. So let's go to the third-party modules, Deno Faker. So this is a package that I want to add. This will generate some fake data. So I'll copy the URL, paste it here, and now the title will become Faker Lorem words 2. Just like that. So let's add the description. This is 10 words. The price. This is image URL. And the last one is the No, this is not the price, this is the image actually, so I made a mistake. And for the price will be a random number till 100. So we created a list with 50 products that we want to insert. In the end, we will await. Since Deno supports top level awaits, this is totally fine to do it here. Products, insert many. And I'll pass the list here. And that's it. So to run this seeder, simply do it like this, Deno run seeder ts. So we need the allow net flag. And it's totally running. So if I check my database now, let's connect with MongoDB. So this is correct. I connected with my local MongoDB database. Let's add the schema. So the schema is a Deno search. If I see here, we have the collection products. If I go there, we have some products that we inserted. Not sure why there are 20, but it doesn't matter. So we inserted these products, and now our endpoint will return products. So I forgot to restart the server. So like this. And now we are getting these products. So this is the front-end endpoint. Now let's add the backend endpoint. Let's go to app.ts. This will be almost similar with the front-end one, so backend here. And here I will add the variable options, which will be an empty object. And when we find the products, I'll pass the options, which currently will return all the products. So if I go to the backend, we can see that we are returning the same products. So this is almost similar than this one. Now in the backend, we want to add a search. So let's we want to search by this word here. If I send this request, I want to filter all the items that have the title that contains this word. So to do that, we have to change the options. So first we want to get this search param here, and to do that we have to add here the request. And I will get the search value from the request, URL, search params, get s, or empty string if the search is not set. So if the search is set, then we want to change the options. So the options in this case will be equal to the title should contain the string. In order to contain that value, we have to use a regular expression. So title will be equal to new regular expression, and we want to pass here as to string as a string value, and we want to pass the I as an option. So that is a new option now, and this basically means the title should contain these strings. So let's try it. Send request, and we got this item, this one, and this one. So all of these three items have this word in the title. So we can see that it is working fine. But we want also to search for this word in the description. This one does have it, but this doesn't. So we want to search the title or the description should have this word, and we need to add an or condition here. So to do that, I will cut this and I will add an or condition that this accepts an array. So I'll make an object here. I'll paste the title that we added before. I'll duplicate this, and let's do the same for the description. And with this, this means that the title or the description should contain this string. And if I do it like this, we get 3 items here. If I send a request, we will probably get more. So as you can see, this word doesn't belong in the title, but it does belong to the description here. So we are getting more items. So this is how we search for the title and for the description. Now we want to do the same, and we want to pass a sort here, and we want to sort in ascending and descending order based on the price. So to do that, I will copy this, and we need the sort again here, sort. And if the sort is set, we want to do something. So we added the options here, but we have to add also find options, which this will do extra stuff like sorting, etc. So we will pass the find options here after the options, and this won't change anything if I send this request. So nothing has changed here. But if the sort is set, then let's change the order. So find options now will be equal to an object. Inside I'll pass the sort, which is also an object, and we want to specify the column that we want to sort. So we want to sort by the price. So price. And now the value here is 1 if we want to sort ascending, and -1 if we want to sort descending. So to do it, I will use it sort to string to lowercase. Is it equal to ascending? Then I will return 1. Otherwise, I will return -1. So I will convert it to lowercase because if we send it like this, it will not sort it ascending. So let's see if this sorts the items. Let's send the request. The first product is 16, 26, 36, 44, etc. So they are sorted in ascending order. I can remove the search here, and I will sort them by descending order. And as you can see, 100, 92, 92, etc. They are sorted in descending order. So this is how we search and we sort. So we can use them both at the same time. Now let's add the last part, which is the pagination. To add the pagination, first let's get the page, which is a number from the request. So this is a page here, and the default value will be 1. We are having a problem, so we want to cast this as a parse int here. Still doesn't work, so I will cast this as any here, and that's it. Now we will have the page as a number, and now we can use this. We need also another variable, which is per page, how many items per page we want, and I want 9 items per page. So we have the page, we have the per page, and now let's use them. So to use them is pretty simple. I will create here, or I won't do it, so I'll cut this. And the response now will have the data, which is this data that we got. But now I will add a limit of per page items. So this means that now this will limit our results to only 9 items. We won't get more than 9 items. And the second one is to add the skip. So by default the page is 1, and if the page is 1, we want the skip to be page minus 1 times per page. This means that if the page is 2, then we will go to the 9th, so we will skip the first 9 items, we will go to the second 9 items. So this is how pagination works. And if I send this request, we'll get data here, and we'll get the first 9 items. So the price is 16 here. If I send the page to 2 here, the price has changed, so we are getting the next 9 items. So let's add some extra configuration so we don't get confused. And to get the extra configuration, we need a variable total, which is the total of the items that are found here when we filter. And to do that, this is equal to products count, and I'll pass the options inside. So let's return also the total. I'll return also the page, and the last value that is needed for the frontend is the last page, which is equal to math seal total divided by per page. So with this, now we will know better. Let's send the request, and in the end we have a total 50 items. We are the second page, and the last page is 6. So we know for sure that we are paginating. And also, if we send these values, the total is 7 in this case, and we don't have any items here because the last page is 1. So if we go to the page number 1, we will get items. So this is how we search, sort, and paginate using Deno and MongoDB. I hope you liked this video, and if you did, also please share and subscribe. Thank you.